Hello everyone, I am Jahangir Akram and I am a chemical engineer. I have done my master's degree from Beijing University of Chemical Technology with research focus on anaerobic digestion. So most of my subscribers already know me because I have been making some videos related to fundamental knowledge of chemical engineering. So such as the design of shell and tube. Anyways, in this video I will be covering the details of anaerobic digestion. Specifically, I will cover the details of biochemical methane potential experiments. Although information is available online on this matter, but I think the information available online is very complex, like because anaerobic digestion is a very simple process, but the information available online complicates it a lot. It's a very simple process. I mean, I will cover all the details without making it any complex. So in the process of anaerobic digestion, uh, waste such as you can see this is fruit waste and this is cow dung. You can utilize these to produce biogas. It's a very simple biochemical process in which you simply insert your feedstocks in certain amount of inoculum, add some water and seal the digesters, because it is called anaerobic digestion because such bacteria and archaea do not operate in under aerobic conditions. So that's why you have to remove the oxygen, seal this waste with water and inoculum, and your reactor or your digester will start producing biogas. So there are different kinds of biodegradable wastes which can be used for this process. Yes, and yes, of course, your feedstock should be biodegradable. For example, you cannot use some non-degradable matter to produce biogas. Especially under anaerobic conditions, because some feedstocks are degradable, but they are not degradable under anaerobic conditions. So you have to study about your feedstock in detail. For example, there are some biodegradable plastics which are not degradable under anaerobic conditions, but under aerobic conditions those are degradable. So you have to carefully study which kind of uh, wastes are degradable under anaerobic conditions and which are degradable under aerobic conditions. So this process is known as anaerobic digestion. Therefore, you will only be choosing those feedstocks which are degradable under anaerobic conditions. So what is we will be talking about the BMP digesters. I will give this is a picture of a digester. I took it from a website of a company. So this, for example, this is Cauldron. It is in it is I am not sure about the actual feedstock which was utilized in this digester, but just as an example, such kind of feedstocks are inserted in these digesters along with some water and inoculum, and these digesters start producing biogas. So I will not try to complicate the process. Simply you can see that this is your feedstock, for example food waste or whatever you added, and it is directly converted into methane. You do not have to go into the details of biochemical pathways. We will cover those in subsequent videos. Right now I think there is no need to go in such details. You can just see that in first stage you insert your feedstock and it is converted into methane and carbon dioxide, which is called biogas. It is a small amount of water is also produced, but generally this is the composition of biogas. So this is an example of a lab scale digester which I used in my master's research. So in this digester I inserted some inoculum, some substrate and water. So this is this how to say inoculum will be converting my substrate into methane, because of that I have to leave some head space above my inoculum, because the biogas will be accumulated in this region. It is important to leave sufficient head space, because leaving less head space can cause this digester to blast. But we will cover those details in subsequent videos, like I mentioned. So, but as I mentioned, any degradable industrial waste or household waste, agricultural waste can be used for this purpose. And as I mentioned, the term inoculum, it is a mixture of bacteria and archaea. So it is produced by cow dung. You can simply prepare a slurry from cow dung. For example, you can seal the cow dung with water for some time under anaerobic conditions so that the anaerobic bacteria and archaea will start growing, and after some time the inoculum will become active, so it can be utilized in anaerobic digesters. Or you can simply take inoculum from some working digester, because they definitely have to discard some they have discards used how to say substrate, or in subsequent cycles they have to discharge some amount of waste, so you can simply use their waste as your inoculum. There is no need to prepare the inoculum from the beginning, because in the beginning I think it will take a long time to uh, initiate the AD if you try to prepare inoculum yourself. So a simple question arises: how much feedstock, water, or inoculum should be inserted? For that, first you need to know the term organic loading. Organic loading means how much substrate and inoculum will be inserted, because these are organic matter which will be present in your digesters. Mostly the unit of organic for the organic loading of solid feedstocks, mostly the volatile solids, um, weight based on volatile solids is used. For example, you will be reading in research articles that 8 gram Vs per liter of feedstock it was used. So it means that the weight was inserted based on the volatile solids. Volatile solids represent the waste, the composition percentage or composition of the waste which is how to say degradable, or which will be converted into biogas. Generally, as a rule of thumb, if a feedstock is highly degradable, you use less organic loading, because, as I mentioned, in this process, in between acids are produced. So if a feedstock is rapidly degradable and you add a lot of feedstock, it will definitely cause acidity in your digester, and because almost a neutral pH is required for optimal operation of your AD, so it will cause disruption in AD. That's why and if your feedstock is less degradable, then of course you have to add more feedstock. For example, this lignocellulosic biomass is less degradable, so maybe you can keep a high organic loading for such feedstocks. In this way, the microbial community will also remain active, and you will also get sufficient methane production from such feedstocks. And for specifically for your own feedstock, you have to do optimization. You have to first experiment. If the information about your feedstock is not available online, generally in research articles most of the feedstocks have already been covered. But maybe if you want to use some unique feedstock, or if you want to know actual methane production for your case, maybe the information available online will give you a rough estimation, and you want to do exact estimation of your feedstocks in AD, maybe you can do some experiments at different organic loadings such as 8, 12, 20, up to 20 for less degradable, and uh, for highly degradable up to 4 or 6 gram volatile solids per liter. So as a rule of thumb, again, same proportion of inoculum and feedstock should be used. But of course, you can vary this proportion. For example, 1:2, 2:1. You can do different experimentation based on your own feedstock, and then define the desired ratio for your operation. Now, I will go directly on the detailed procedure as I mentioned. So, I have made 7 points for biochemical methane production experiments. So initially, you have to add certain amount of inoculum and substrate, as I mentioned. Afterward, don't worry, I will also show you the pictures. Although I do not have a video, but I have captured some pictures during my master's degree, so I will be showing you the pictures which will clarify the process. For now, just read these points. First of all, a certain amount of inoculum and substrate is added. Then certain amount of water is added to obtain the desired overall organic loading. Then this is the head. For example, after you have added your water, you have to flush this headspace with nitrogen to remove oxygen to create anaerobic environment. After that, you have to seal the headspace, And after that you can use pressure gauge and GC to measure methane content and the biogas produced daily. After that you can sum up the daily methane productions to get a cumulative methane yield. For the measurement of biomethane, ideal gas equation is used. So because with pressure gauge you will be measuring pressure, and you utilizing delta P in ideal gas equation, you can easily measure the biomethane or biogas produced every day using ideal gas equation, and you can use molar volume and all those values accordingly. So these are the pictures which I captured during my masters. So as I mentioned, first we will add substrate and inoculum, so some amount of water. Then we use this is a pipe from nitrogen cylinder. I'm not sure, maybe there are some different procedures utilized by different labs, but we used to flush like this. So maybe you can cover this space with your finger or something, or with rubber stopper, and quickly pull this out and seal this head space with rubber stopper. See afterward, this plastic cap has a hole inside this for sampling. After that you can further seal the cap like this. After that you can shift your digester in mesophilic or thermophilic digesters based on your operation. I will cover all those details in next videos because I just wanted to give overview in this video. And this is our pressure gauge fitted with injection needles. So when you will insert this injection needle in this rubber stopper, it will not affect the anaerobic conditions. It will not let the oxygen pass inside it. That's why you have to use such pressure gauges with injection needles like this. It will give you the pressure reading. Every day you have to remove the biogas produced, because if the pressure will keep increasing, this bottle will blast. So you have to remove biogas every day. And you can see that this pipe is inserted in the water in this way. When the biogas will be removed or exhausted from this headspace, it will not let oxygen to get back inside this digester. That's why it is essential to design such bottles carefully. It should be immersed in water so as not to let the oxygen go inside your digester and affect the anaerobic condition. Afterward, you can use gas sampling injections. This one was very slightly expensive, purchased from Agilent, because it does not allow oxygen to get inside it, and it is very precise. So you can take samples from this headspace and insert this sample into GC or methane meters, simple methane meters, and insert all these parameters in ideal gas equation and measure your methane produced from specific feedstock. After that, as I mentioned, you can record your daily methane yields, and if you want cumulative methane yield, you can sum up all your daily methane yields and prepare a graph like that. I will cover all those details in next videos. So if you found this video informative, please like, subscribe and comment, also share. And so in this way I will be able to make more videos on this topic, because I first want to know if there is sufficient audience of this topic or not. If there is sufficient audience, then I will make more videos. And in case you want to get guidance or consultancy or collaboration and related to your digester or your feedstock, you can also reach out to me at my email, because I will be pursuing my PhD soon, probably on the same topic. So maybe I can at least provide you some guidance related to your feedstock based upon my experience. I have almost 3 years of research experience in this topic. So please don't forget to like, subscribe and share.